All right, for this problem, we're finding the definite integral, and the first step is to find an antiderivative. Well, let's just try to recall, using our memory, I suppose, that the derivative of sine inverse x, also called arcsine of x, is 1 over radical 1 minus x squared. So it's sort of a thing where you either know that or you don't. If you don't know that, it's sort of at a dead end here. So here we're using the variable r, but the antiderivative of 1 over radical 1 minus r squared is sine inverse r. And then we'll just evaluate that from 0 to rad 3 over 2. So that gives us sine inverse rad 3 over 2 minus sine inverse of 0. And what's going on here is we're trying to find an angle. When I evaluate sine inverse rad 3 over 2, I'm trying to find an angle where the, say an angle theta, where sine of theta is equal to rad 3 over 2. And if we think of a right triangle, which is okay since we're looking at since sine of theta is equal to a positive number, then we can use a right triangle. We can look for an acute angle. But sine is opposite over hypotenuse, so your opposite of theta is rad 3. It's rad 3, and then the hypotenuse makes 2, and then the idea is that we can recognize that's 60 degrees. Our answer should not be 60 degrees, though, because everything's set up in terms of radians. And then we also have that sine of 0 is equal to 0, which is something we can see in my little tiny, maybe too small unit circle here. That at zero, the coordinates on a unit circle are 1, 0, and sine of, well, sine of 0, 0. So sine is the y coordinate on the unit circle, so it's going to be minus 0, and that equals pi over 3. And then what I'm going to do is double check to see if that's, well, double check, is that the right question even? But yeah, that is. And then I go over to 41. Shouldn't have to do that, but anyway, that's pi over 3. Let's check out another problem here. This problem's a little more involved. So anyway, this problem was essentially using this derivative of sine inverse x. So if we don't have that, then we can do the problem if we don't know this, but the way we would do it is methods that we won't get to until section 7.3, which is, another chapter. Okay, so let's check out this one. Well, for one thing, we have to think about this a little bit. So first of all, let's just play around with factoring t squared minus 1 to t minus 1 and t plus 1. And then factoring t to the fourth minus 1. Well, t to the fourth is t squared minus t squared squared minus 1 squared. So that's going to make t squared minus 1, t squared plus 1. Actually, now that I did that, I see that maybe I don't even, in fact, want to factor the numerator because of the cancellation here. So this is going to give t squared minus 1, and then t to the fourth minus 1 is t squared squared minus 1 squared. So it's going to be t squared minus 1, t squared plus 1. And then those will factor out. And so, in fact, this guy is equal to 0 to 1 over rad 3 of 1 over t squared plus 1. And by the way, well, hold on. Why am I putting u here? This is supposed to be dt, unless I wrote down the problem wrong. So, but by the way, 1 over rad 3 is look, t squared minus 1 is equal to 0 at 1 and negative 1, and 1 does not lie between 0 and rad 3, so we don't have to worry about dealing with that issue. But 43, yeah, I just put du instead of dt for some funny reason. And then the thing is that we are supposed to know that d dx of tangent inverse x is equal to 1 over 1 plus x squared, or 1 over x squared plus 1, so that the antiderivative of this one right here is arctan, or tangent inverse, of t, where we go from 0 to 1 over rad 3. And so this will give arctan 1 over rad 3 minus arctan 0. And maybe I'll do the low-hanging fruit first to get arctangent 0, which I hope it's much easier if you know that that's just equal to 0, because tangent 0 is 0. But I'm going to just reinforce that. So tangent 0 is equal to 0 over 1, which is equal to 0. Okay, so this guy is equal to 0. All right, now what about 1 over rad 3? We're looking at tangent of some angle is equal to 1 over rad 3. Well, I can draw my triangle now. It's not quite perfectly to scale there, but okay. Tangents, and I wrote it down wrong. Tangent is opposite over adjacent. So I write opposite of my angle as being 1 and adjacent is rad 3. And we're hoping that, that you can recognize this as a 30-degree angle, but we're not supposed to write 30 degrees because calculus is all set up in radians. So we get pi over 6. And that's that. So that knocks off these two problems. And zoom out for the whole thing there. So it's section 5.4, number 41.